this lecture is on the lungs. So we have finally gotten to the lower respiratory tract. So the lungs then have distinct lobes. That are separated by deep fissures. So what's that look like now? What I'm going to do next is just draw a diagram. This is strictly diagrammatic, but I think it should help. So we have the trachea again, and we have the two primary bronchi. There we go. Here's the trachea with its cartilage reinforcements, and the primary bronchi with their cartilage reinforcements. And now I am drawing out the lungs. Hang on a moment. Let's do this nicely. So here we have one lung. Here we have the side of the other lung. Here we go. Remember that this is the right, and this then is the left. And then over on this side, we have the lobes. This is strictly diagrammatic. Keep this in mind. And the fissures here. And what I'm getting at is that down at the bottom, we have the diaphragm. And here we have the lungs then resting on the diaphragm. So what do we have here? Here we have the superior lobe of the right lung. Here we have the middle lobe of the right lung. And here we have the inferior lobe of the right lung. Over here we have the superior lobe of the left lung and the inferior lobe of the left lung. So here you have the trachea. Here you have the two primary bronchi. So, the lungs then. The right lung then has 3 lobes. That's a 3 there. 3 lobes, and they are, as I have indicated there, the superior is the top lobe. The middle is the middle lobe. And the third one then is the inferior lobe. That's the right lung. And then the left lung, I'll do it this way, has 2 lobes. First, the superior, and then second, the inferior. Okay, then at the top you have, then this is just some more terminology, you have the apex, of the lung, which is at the top. And then you have the base of the lung, which is concave. And I'm just going to continue that thought here. So the base then rests on the diaphragm. And the diaphragm, I hope you remember, is that dome-shaped muscle at the bottom of the chest. So what is happening here is, here you have the diaphragm, that very thin dome-shaped muscle. This is the thing located at the bottom of your chest, that when that dome muscle contracts, it goes down like this. That's what expands your lungs and draws the air in. So the base of the lung then is resting right on the diaphragm. Okay, so now we are getting into the interior structure of the lung, and that goes like this. So the connective tissues then from the root of the lung. You remember up here we have connective tissues anchoring this all in. But these connective tissue fibers then also go into the lung itself, and they start dividing the lung up, basically. So connective tissues from the root of the lung then extend into the lung, dividing the lungs into smaller and smaller compartments. And then meanwhile, so you have the lung being divided up basically into little rooms, if you will. And then the branches of the conducting passageways. Conducting passageways is the physiological term for the air tubes. So branches of the conducting passageways pulmonary blood vessels and nerves. So all those things that entered the lung at the root of the lung are basically carrying along then. So all of these different aspects of the lungs then follow these partitions. So we have these partitions made up of connective tissue, basically little walls, if you will, and following along these partitions, you've also got blood vessels, you've got the air tubes, you've got the nerves. So everything is following along these connective tissue partitions that are called trabeculae. That's an E. There we go. And the terminal partitions, that is to say the terminal walls, so you have the lung being divided up basically into little rooms with little walls, and the walls contain all these things. So the terminal partitions then that are now called septa, it's an A, septa. Let's do this. Let's make that a colon. Called septa then divide the lung into lobules. So each lobule then is served by tributaries of the pulmonary arteries, pulmonary veins, and respiratory passageways, the air tubes again. So every single lobule has all of these things in it. And then also, throughout the lung, another structural feature then are your elastin fibers. And these are in the trabeculae, in the septa, and in the pleura. Then these elastin fibers make the lung highly elastic and therefore capable of tolerating great changes in volume, which is absolutely crucial for your lungs, as I'm sure you can see. Again, you have the dome-shaped diaphragm at the bottom. It is increasing your whole lung capacity briefly. But to do that, your lungs have to be able to expand. They can only do that with lots of elastic tissue. And then, of course, the lungs contract back. The elastic fibers doing a lot of that contraction all by themselves. You can also push in and then breathe back out. But it is only because of these elastic fibers that you can actually wind up tolerating these remarkable changes in volume that you wind up seeing in the lungs. And that's it for this lecture.